Well, hope everybody's doing pretty good tonight. This is some 23-year-old footage. I didn't happen to have any time-lapse ready, so I figured I would just show you that very quickly for tonight. That was taken at Dyess Air Force Base. I set a camera out at the weather station and took some footage there. And that's what we used. Anyway, for tonight, let me get this all set up here. Alright, we've got some changes in store for especially the East Coast. You can see, let's look at the long wave trough pattern. Let me get my tools set up here. And we're talking about the large scale waves. And there's two of them on the chart right now. We've got this long wave ridge out west, which is only broken by this, maybe we could call that a Rex block. A little pressure right down here. And then we have a shortwave, or I'm sorry, a long wave trough out on the East Coast, about like that. Maybe a little further, maybe something like this here. And you can see that superimposed on that trough pattern we have short waves. These are probably major shortwaves. There's one there coming in from the Hudson Bay region and Manitoba. Another one just off the East Coast right there. And we can't just talk in terms of troughs. We've also got major shortwave ridges. So between every trough you have a ridge, and there's one. And going further out west, there's one way out here in British Columbia, right about there. And then going down into the Pacific, we could probably put a major trough in here. And then superimposed on that, you can see we have even smaller troughs. So there's one there. There's maybe a channeled pattern in here. There's a trough right here coming through northern Manitoba and Hudson Bay. There's another one right here through Washington and New Jersey. Another one off here. So you can see that we have troughs at all different scales. There's probably at least 3 different scales on this chart here. And each of them has a vertical motion field. So the most significant one that we're looking at on this chart is probably this one here, coming out of Manitoba and Ontario right there. So let me check my levels right here. Everything is looking good. Might have to back off from the mic a little bit. Okay, then here in Texas, so we have this cutoff low, and we call that cutoff because it is detached from the main polar front jet, which is probably something like that. Maybe not so sloppy, but one here. Let's see, let me try to find a different pen. Can't find a good pen color here. I'm going to try using red. Okay, so these are the main polar front jets, and you can see that cutoff low is well south of that pattern. So what's that cutoff low doing? Well, we can probably take a look at some of the soundings. Let's do that. For models, I'm going to use the University of Wyoming website, since they do tend to be pretty timely. And their website comes up with this map here, and you have to set this plot to skew T. And I'm going to pull up El Paso. We're going to look right into the heart of that upper level low. So what do we see here? We see pretty steep lapse rates. Below 750, you can see that it's pretty much dry adiabatic. So probably some very strong surface heating. And above that, we're moist adiabatic, like that. So they're leaning pretty far off to the left. We don't have that tray standing up like that we have at most stations. And what else do we have here? It looks like very cool conditions in the mid and upper levels of the atmosphere. So 700 millibars. We're looking at freezing conditions. So the freezing level is down to 10,000, which is pretty low for that area. And then above that, at 18,000 feet, 500 millibars, we have a temperature of about minus 19 Celsius. So this is very cool mid and upper level air that's drifting through that area. And as a consequence, very low densities through that layer, and that's going to reflect as very low 1,000 through 500 millibar thickness. And looks like the troposphere is pretty low too. 30,000 feet right there, 300 millibars. Above that, we have the stratosphere. And what kind of conditions do we have at El Paso? We can go to the METARs from NOAA. Sometimes during the spring, you tend to get thunderstorms, and you can get some very photogenic thunderstorms. We're talking like low-top supercells and some really big hailers. I'm not sure if we have the instability for that today, but let's see what El Paso is reporting here. Looks like a lot of broken clouds at 8,000 feet, a lot of mid-level clouds. They've got a report here last hour of occasional lightning and cloud, distant south, and cumulonimbus cloud different south. So it looks like there is a little bit of instability taking place there. We have this northeast flow. So cool winds coming over the Guadalupe Peak Mountains, Davis Mountains. Actually, I'm not sure what mountains that would be in that part of Texas. Davis is a little bit further south, like in this area. There's some mountains here, I can't remember what they're called, but Guadalupe Peak is along there and just north of there. But anyway, we have northeast flow across that area. All right, let's take a look at the satellite data, and we'll take a quick look in that upper level low. And we do see a lot of different low, mid, and high clouds kind of banded through here. Let me bring up the state borders. And this was taken about 11 or 12 in the morning. So let's see, what we're seeing here is mostly mid cloud layers. Not a whole lot of instability taking place here right now. Okay, let's go to the structural thermal pattern across the U.S. and we work through our thickness chart. You can see a very strong front coming through the Great Lakes area right there. So that's probably bringing some very sharp temperature changes. Maybe a warm front kind of like that, an included front going through the Canadian Maritimes up through Quebec. Out west, not a whole lot going on, just kind of very warm weather. Looks like maybe a front offshore, right off the left edge of the chart. And we probably do have a weak front in Texas because you can see there is a temperature gradient through here, a thickness gradient. So we might look for maybe a front kind of like this, just off the South Texas coast. Let's see, does the surface data actually reflect any of this? Yeah, definitely, right through here. Very strong front coming through Ontario. Let's look at just one station. And I'll show you how to look at trends and how to look for a frontal passage in the METAR data. We're going to take the station YXR. I'm going to go back to the METAR page and put in CYXR. I'm not sure what site that is. Maybe North Bay. Let me go back. I want to get a time trend here. Okay. Can you see what time the front came through? The date and time is over here on the left, and you can see it increases up the page. The most obvious thing here is the change in the winds. You can see earlier in the day we were looking at westerly winds, 11 gusting to 17, and then later on we were northwest at 25 gusting to 32. And these are knots. So this is actually like 28 miles an hour, gusting to about 37 to 38. This is very gusty conditions. Looks like the change was maybe right in here. And really the key discriminator is going to be temperature, because that's the definition of a front is density changes, which are manifested by temperature. And it looks like they really start dropping off between here and here. So this is right around this time here. So it looks like this front came through maybe, I would say with this observation right here, 0033. And if you actually do this at a bunch of different stations, you can plot an isochrone chart to actually show the progression of the front with time. And I've done that in a few case studies, and that can be helpful because you can use that to project the front ahead and find when it's going to hit these other stations. So the front came through about 45 minutes ago at that station, and it's on its way into the northeast U.S. Elsewhere in the U.S., high pressure centered on Tennessee. So that's given us a weak northerly flow along the U.S. Gulf Coast, and then some southerly flow on the west side back here in the Central Plains. And there's that front down to the south. Looks like a very shallow front is pushed all the way down to the Mexican coast, and we talked about that a couple days ago. Look at those gusty winds right here. That's a good sign that you've had a cold frontal passage through there. This is kind of like a mountain pass area. And you can see the way it's banked up against the mountains here, and that's what gives us a lot of low ceilings in this part of Mexico. We're getting that upslope flow through that area. And then embedded in all that, the cutoff low is located south of El Paso in that area. Don't really see much of a reflection of that at the surface. And let's see, out west, very quiet weather. And I'll show you very quickly what's going on in Russia, since we don't have a whole lot of winter weather here. This is Siberia, and you can see some very cold temperatures. We're looking at below -20 in this entire area. That's a very large area there, so we're not just looking at global warming or anything like that here in North America. you just go elsewhere around the world, and we're definitely getting some very cold polar air production going on. And eventually that'll catch up with us, and we'll see some of that in Canada. But not this week. So let's go into the forecast. I can give you the short-term forecast here using the NAM for the next 2 days. Upper level chart showing that trough moving southeastward into the northeast U.S. right there. And this is a reflection of course, the cool air moving southeast through Ontario. And a big ridge building across the central U.S. right there, so things are going to be kind of mild across the central plains. And here comes the next trough onshore into the western U.S. here. So that's going to be our next big change here over the next few days. So we'll drop down to the GFS chart and take a look at that. Let me get this all lined up. Okay, starting out. Later tonight, cold front dropping into the northeast U.S. and high pressure, very large high across the northern plains, which is actually bringing warm air north into the Canadian prairies, and it's bringing cold air south into the northeastern U.S. like that. Here's our next system coming on shore right there, just west of Oregon. Go forward a few days, that Pacific system moves onshore, but you can see it weakens a little bit. Looks like a bit of a, let's see here, yeah, this is a blob of warm air in the northern plains, just north of this high pressure area that's moving southeastward through the eastern U.S. So you can see that high just kind of settles in towards the southeast U.S. We get another shot of cold air coming into the Great Lakes. This is going to be on Monday, just after the weekend. Here's our next system shaping up here. It looks like it's even stronger than the models had forecasted yesterday. This is on Wednesday. So this is a good shot of cold air coming into Oregon, Nevada, and California. That'll probably be affecting this area as we go forward. And yeah, looks like we've got a strong system coming together in the Great Basin area for Thursday. And look at that 540 line coming all the way into Nevada right there. And the 540 line is a discriminator for winter weather. And there we go. There's our Great Plains system here. If we have enough moisture, we'll have the possibility for thunderstorms. About a week from now, this is going to be Friday. And there it comes out into the Mississippi River Valley. Cold air punching through into Texas and Arkansas by Saturday next week. And then next under the gun will be the eastern U.S. And that's going to drag a pretty good chunk of Arctic air southward just after the weekend. And you can see this is 300 hours out, but the main band of very strong thickness is pretty far south. Instead of finding that up in Canada, it's all the way down in this area right here. So that's going to do it for me. I appreciate you watching, and we'll see you tomorrow. Let me check over the chat. Okay, no problems there. So, yeah, we'll see you all tomorrow, and I appreciate you watching. Thanks.